This is AP Computer Science A with the Arupe Virtual Learning Institute. My name is John Maxwell, and tonight we're going to discuss the decomposition of programs into methods. I think that's really exciting. But not, we haven't got you following this, right? Anyways, we'll talk about breaking down the work in a particular class amongst many methods and what are the advantages of these methods. We'll also look into reinforcing the method signature and what that means in terms of the method's use and what it will return. We'll move forward from that point and talk about static versus non-static methods and get a better understanding of the static keyword. And so, with our work ahead of us, and if you're in the class, you can download this file and look at it too on your computer. We ran a poll last night, and half of the people opened the files that I send in the weekly emails, and half did not. So I imagine, though it was a limited number at the synchronous meeting, that a fair number of you may not open it. No matter, you can look at it on the screen. So we have a main method and a number of other ones, and you can see the main signature is on line 4, and then there is a method that calculates the mean ACA average, which is on line 12, and a method that finds the mode, which is the most frequently occurring number in a list of numbers, and that signature is on line 20. And down near the bottom you can see something that finds the maximum value and returns the int, which is the index position where that maximum value is located, and that signature is on line 35. Now, in the reading or the look through on IMAX, you'll find that public means that it could be used outside the class. Up till now, we haven't really seen how that might be done in our work, but it means it's accessible outside the class for use by another class, in fact. So if another class wanted to use the mean method, ignore what was in the main, or just use the find mode, it could. Okay, and so that's something that you want to consider. I don't want to get into really use of the static method here. My goal is to discuss the decomposition of a particular program into methods. And so at the start on lines 6 and 7, we declare two int arrays, and they're A and B respectively. And we do that so that we can, perhaps process them both. And here we have on line 8 a call to the mean method, which sends in the int array known as A, in where it becomes nums, or nums is an alias of A. They both point to the same object in memory, and you can just keep that in your mind for a second. It's like something called A and something called nums both point to where the values are stored in memory, the reference, the memory address. So it's like two fingers pointing at you. So in order to calculate the mean or the average, you have to sum the values, and in line 14 through 16 we see the use of a for each loop where each element in nums is dumped into x, and x is added to the sum until all the values in nums have been exhausted. So the for each loop is a straight through, no stopping, no reference by index. So we learned about that last week. And it returns the average. So run it and ask the question for you briefly, what I asked the class tonight. Why is the average 7.0 in here when I think it's probably something different? Look over lines 12, which return a double here, and through 18 to see if you can guess what they guessed. Well, one of the students said make sum a double, and that certainly would work. I also referenced the more obscure option of doing this and asked a student to identify it, and he quickly chipped in that what we're doing is casting sum as a double. And so as soon as we have a double involved in any type of arithmetic, a double will be returned. So this calculates out the mean. And if I run it again, instead of 7.0, I should get an actual better conversation, which is 7.125, which is the actual mean of the interarray known as A. Now, that's all very good, right? And the beauty of like breaking it down into methods is I could change this to B. First I asked, why is it better to put mean over in its own method and not in the main, and find mode in its own method and not in the main? What are the advantages? And somebody said, well, it's better organized. And I chipped in and said, yeah, you could change one part of the software, and the rest of it doesn't need to be changed, so it allows you to go directly to a particular thing and change it. Maybe when search results are rated, there are various elements that go into that rating, and if there's a method that just tweaks one part of the rating, you could just change that, and the Google search result algorithm would produce a slightly different result based on their changes to just one method, while the rest of the system goes on where almost. Well, that's good. Reusability is another one, and so I'll just put B in here. And as long as, because it is an int array, nums, as long as it is given an int array, okay, then it will work, right? So reusability, the average in this case is 70.16666 forever. Okay, so it's reusability, it's organization, it's the ability to change or edit one part of the system, in this case just one file, and that's kind of nice. So I'll change this back to A, and we'll go on with find mode. It deserves a little look, okay, because find mode operates on a concept called parallel arrays. Okay, you have the array of numbers, and the numbers, when it gets into find mode, are these values, nums. A gets sent, again the alias of A is nums, and we create a new array called frequency, or FREQ, short for frequency, that contains the frequency of each number in the array. So in the 0 position, the frequency array, there would be 1 at the end of this processing down below, because the 15 occurs once. And in the 1 position of the frequency array, after the code gets done, since there's only one value, 1 would be stored at index 1 in frequency, and 7 minus 7, there's only 1 minus 7, so 1 would be in the 2 position. But when it gets to 12, in each of these cases, it's obvious that this is the most frequently occurring number. But when it gets to 12, it will store 2 in that position in the frequency array. So using a nested for loop, we examine every element in this frequency array right here against every other element, including itself. And when the elements are equal, it increases the value stored at the similar index x. Well, now we have a frequency array that's populated with numbers, values which indicate at a particular index position how many times that value it that num's index position is found in the remaining part of the array. So in order to find the max, we go to another method, and I could actually make this private because it's only used within the class. And so I'll just leave that aside for a second. It's just a throwaway for you in the future, a little, breadcrumb. Okay. So it returns the index of the value which is the highest in the frequency array, because frequency array gets sent. We say max is, for sake of argument, the first value, and that the first index, for sake of argument, is 0. Whenever we find one that's bigger than that, okay, after running through all the values, we'll store that as max, and we'll store that index in max index and return max index, which is used to return to up here. So we see information being processed between methods. Wow. Income parameters, out go return types, if there is one. Void means there's no return type or no return expected. So we begin to see the other element of methods which I want to discuss, which is, not only do they keep them organized and they're reusable and you can go there and edit them easily and tweak one part of the software system, they're really central to the communication within the software system. Values get passed in and out, and processed in ways that are expected, and that communication element is something that you're probably thinking, wow, and a good programmer knows what goes in and what comes out. So this is my argument for using methods. But let's dig a little deeper into the static word. So hopefully you were with me. Okay? So static and non-static. Okay? We're going to go back to old times, which is like probably currently, because no matter what we have with strings, they always seem to turn up. And so I create a string called test, and it holds the value pat. And test can call a substring method, which is part of the string library or class, and get the first value, okay, which is p. Starting at index 0 and ending 1 less than index 1, which is starting and ending at 0, we get the value p. But the key is that substring must not be a static method, because it's called by an instance of the string class. Test is an instance of the string class, also known as small o object. Okay. And I say that purposely. There's something called big O object with a capital O. But it's an object of the string type. So, or an instance. Substring is not a static method. Okay. But math.square root is, and the square root of 25 is 5.0. Okay. It's called by the class name. Oh, great. That sounds wonderful. That too bad people don't make classes, that have lots of static methods. Well, they do. There's a lot of them in the Java API, which I encourage you to go out to the browser, pause the video, and type Java API, and just see how many libraries and classes there are. Wander a bit. It doesn't have to be formal learning. It could just be learning by wandering. Okay, back to the video here. So a static method can be called by a class name. So what I did here is create a method here. Look, no main. One that calculates the mean of a double array and the sum of a double array. Hey, guess what? Like, we return the return from sums, which is a double, and divide it by num.length. So here's another example of a private method. Sum only lives to serve the mean method. Okay, can't be called from outside the class. Find max, we already kind of described what that is. It creates these parallel arrays. Okay, so no, that was find mode, and what happens is find max is used by find mode, and we've already discussed the algorithm that finds the maximum value in an array. I believe it was in last week's video. I'm not really sure. And then there's some fancy statistics. Find the standard deviation, which is the average of all differences from the mean. Okay, so you kind of sum up all the differences, and then calculate out that difference. It's the square difference from the mean. Okay, you can look at the calculation. Matter of fact, the calculation could be good for last week's assignment. So if you're behind on your assignments, look at this before doing the statistics IMAX assignment. Okay, and then there's z-score, which is a measure of how much any one value, like your test score, deviates from the mean, and then it's expressed in statistical terms as a z-score. Okay, so they use this against you when they compare all the test scores in a particular class. And if you have a high negative z-score, then you're in troubles. Okay, the z-scores are, by the way, between -4 and 4. So if you're up at 4, you're probably not going to get much of a curve because you're pretty near 100 anyways. Z-scores. Hey, but look at this. There's no main. Remember? No main? No main? Stat tester. I can use this other class, statistics max. I named it after myself, right? Statistic max. To call any of these methods, not only on mint, but double or any double array that I want. Okay? So I'm just going to change these to DBL. Stick it not on mint, DBL. I think I'll make it mint. Mint, double mint. I don't think you know the name of that gum, do you? Am I being old on you now? Ooh, so sorry. Here we go. Alright, the mean of the top numbers is 3.65. The mode is 3.5. That's true, right? The standard deviation of all the values, the average of all the values and how far they deviate from that mean is 2.97, okay? And any particular z-score of how much it particularly deviates at index 0, it's 3.5. It's a little lower than the mean, minus 0.05. The mean is 3.65, and the last number is like 7.5, and it shows that it's 1.29. And remember, the values are either -4 to +4, so something that's a little over 1 is not outrageous. Everybody fits into the mean. Okay, but the real value is, here's this class that I've developed with static methods here that can just be used in another class with a main, simply by using the name of the class name and invoking the method. Wow. And invoking them on whatever, double array I have. Double array. So there you go. All right. You look at those and see how those go together. Stat tester and statistic max. Okay. I don't know how long this is going, but like I hope it's going. Oh yeah, the red button is on, so I'm still recording. Being funny tonight. Okay. Insert and delete. Okay. This is a like, what if you wanted to insert a value at a particular spot in the array without losing any of the values that are already in the array? Like you wanted to put something in an index 1, there was something already there. You don't want to overwrite it, but you want to keep the order. It's called insertion algorithm. And then this question on the other hand is, what if you don't like a value at a particular index and you want to remove it, but you don't want to leave a gap in your array? This will never be tested, but hey, it's so real world, inserting an element in the middle of an array. Lot of moving. Oh no, moving. Anyways, that is awful. I should just leave the comments on to think what you were going to say about that. We've got two arrays. One array, numbers. It's a real New York thing, huh? Numbers. And then it's got up to space for up to 5 values stored in 0, indexed through 4. And then I use this cascading assignment. I guess you probably are unfamiliar with this. Numbers 0 equal numbers 1 equal numbers 2 equal 5. And so the indices 1, 0, and 2 all have the value 5. So now we say, oh, we want 13 in there, and we want to put it in index 1. Well, what's at index 1? 5. I put it right here at 5 in this cascading statement. So how does insertion work? And I asked, and someone said, you have to shift forward, and it was like, whoa, you're looking at it the wrong way. You need to shift all the values back. So why don't we go to one less than the length, the last value, okay, at I, and go down to the index, which was 1. We want to put 13 at 1, and then go down and then say the value at I is the value before it. In other words, we're shifting values out towards the end. And when we get down to index, we just assign the value. Well, let me show you. After 13 is put in, 5, 13, 5, 5, 0. Okay, what's beauteous about this? Okay, couldn't do it with a for each loop. That's just straightforward from beginning to end. Okay, no stopping, no index square bracing or anything like that. But with a traditional for loop, you can start at the end and move to a particular point. And in this place, it's the place you want to insert by decreasing. So you can attack arrays both ways. So you need to free your mind. Sometimes the problem will require you to look at or go at it a different way. Now, insertion. Start at last index, decreasing by 1 until we reach the index position to be inserted. Shift values up towards n, provided there's space in the array. But hey, take a look. I made space in the array. I made 5 and I only put 3 values in. Okay, we're not covering tonight, and you won't be asked on the AP exam, what about if there's no space? Well, you gotta double the size and copy it all over. Okay, here we're gonna remove. To remove, start at the index where the value is to be removed and just shift values down. All you do is tumble the value after it on top of the value you want to get rid of. I've been crushed by the one after. Okay, and that's what happens. You start at the index and you say, I'm equal to the one after it, me. And that's how you remove. We use arrays.toString, which is the arrays library up here. A lot of great stuff. Hope you looked at the Java API for arrays. Stop that train. listening to that song. Anyways, I'm done. Did you see that? It removed 13 right down there. All right, another beautiful program to look at. And, you know, from experience, I used to sign this as a lab. I'm not going to. Okay, like you figure out how to do insert and remove. Well, I don't have to show you. And I used to sign as a lab, and it was a very difficult lab because, like, people had to think of how to approach it. And while we're at it, if you just like cop out and do a chat GPT, you're missing the thinking part, and then what happens to your brain? Oh no. Did you not think about it? Okay, so I'm giving it to you. I'm your AI tonight. And with that, I think you know when I recorded it, I am signing off. Sorry for making it a little longer for the stupid jokes that he sold and told all night.